Chapter 3 Linear Regression. The concept of linear regression was first time given by Sir Francis Galton when he was studying about inheritance. Inheritance means genetical characteristics which are received by children from their parents. So at that time, first time he gave or he taught the idea of regression. Basically, as we know, when there are two variables associated with some sort of cause and effect relationship, there exists correlation between them. If x and y are associated with some sort of cause and effect relationship, where one variable is reason and the other variable is result, then there exists correlation. Now, one step ahead. When there is increase in value of one variable, what will be the likely change in the value of another variable? That is called regression. To estimate the value of one variable on the basis of the given value of another variable. So for this purpose, these two variables which are associated with some cause and effect relationship are to be understood in a way of dependent variable and independent variable. Generally, x is considered to be the independent variable, which is cause, like price, and y, that is dependent variable, that is result. You can say demand. So if there is increase in price, there will be decrease in demand, or if there is decrease in price, there is increase in demand. Or rainfall and crop production. If rainfall increases, crop production will also increase, and vice versa. So these are some set of variables which are associated with some sort of cause and effect relationship. Now, if there is increase in value of x by 1 unit, then what will be the value of another variable, that is y? Or what change will be anticipated in the value of y with the increase or decrease in value of variable x. So if these type of relation can be exist or can be established with the help of some mathematical or statistical function, it is called regression model. And if such type of relation can be established with the help of linearity, it is called linear regression. So linear regression or model or linear regression equation is basically a statistical or mathematical model where dependent variable y is expressed in form of appropriate mathematical function of independent variable x, where y is equal to dependent variable, x is equal to independent variable, and a and b, or you can say alpha and beta, are considered to be the constant. So with the given value of independent variable, you can estimate the value of dependent variable with the help of regression model. So this is the definition of linear regression. A mathematical or functional relationship between two correlated variables which helps in estimating the value of dependent variable for some given or known value of independent variable is called linear regression. So whenever you are given the value of x, what will be the estimated or predicted value of y? That is called regression. And the equation or the function with which you can find out this estimated value, that is called linear regression model or linear regression line or linear regression equation. So basically there are two methods of fitting this regression line: method of scatter diagram and method of least square. So under method of scatter diagram, we will use graphical method. We will plot the value of x and y on the graph paper, and with the help of that we will establish a functional relationship between x and y. With the given value of x, we can derive the estimated value of y. Now the second method, which is the most prominent one, method of least square. This method was given by statistician C.F. Gauss. C.F.G.A.U.A.S.S. So under this method, we will establish a relationship between x and y in some form of mathematical or statistical function, using which we will find the estimated value of y with the given value of x. Regression line or regression equation of y on x. Basically, there are two regression lines. Regression line of y on x and regression line of x on y. With the use of regression line of y on x, you can find the estimated value of y for the given value of x. And with the use of regression line of x on y, you can find the estimated value of x with the given value of y. But in your syllabus, there is only one regression line, that is y on x. It is also known as best fitted regression line, where we can find out the estimated value of dependent variable for the given value of independent variable. Y cap, that is estimated value of y, is equal to a plus b into x. Here b means regression coefficient of y on x. A is a constant which is equal to y bar minus b x bar. Y bar means mean of y and x bar means mean of x. Now there are different formula to find out value of b. All the formula which we used in correlation, same will be applied with little bit modification. First, when observations are small, that is value of x and y are basically less than 30. Formula to find b: n into sigma xy minus sigma x into sigma y upon n into sigma x square minus sigma x whole square. Okay. In correlation, the denominator was different, having square root both value of x and y. But in regression, we are finding out regression line of y on x. So in denominator, there will be only part of x, and that is also without square root. x bar and y bar are integers, non-fraction, non-decimal value. Then b is equal to sigma x into x bar, x minus x bar into y minus y bar upon sigma x minus x bar whole square. Now, when observations are large or x bar and y bar are non-integer, or value of x and y are in decimal or are too much large, or they are divisible by some particular number, then we will apply the formula of assuming, that is UV. Now, this part is new. Cy upon Cx. Suppose all the observation of y are divisible by 10, then class length of y is 10, and all observation of x are divisible by 5, then class length is 5. Unlike correlation, the regression coefficient is free from change of origin but not free from change of scale. Means addition subtraction will not have any effect on regression, but multiplication division will have. So whenever we are adding or subtracting a particular number from all the observation, the value of regression coefficient will be unchanged. But if you are multiplying or if you are adding, or if you are multiplying or you are dividing value of x or y, it will have certain impact. So that's why we are multiplying with Cy upon Cx. regression ઉપર એડિશન સબટ્રેક્શન ની ઇફેક્ટ નહીં થાય, બટ મલ્ટીપ્લિકેશન ડિવિઝન ની થશે. બરાબર? ના, બટ તમે મલ્ટીપ્લિકેશન ડિવિઝન ના કરો, then it is okay. If you have divided or multiplied value of x and y, then and then this term will have value, otherwise it will be 1. If I have divided value of x by 5, then Cx will be 5. If I have divided value of y by 10, then Cy will be 10. But instead of dividing y, if I have multiplied y, then Cy will be in the denominator, reciprocal, 1 upon 10 થઈ જશે. And instead of multiplying or instead of dividing x, if I multiply value of x by 100, instead of denominator, it will come into numerator.
સર આપણે b કોઈ પણ મેથડ થી ફાઇન્ડ કરીએ તો આન્સર એ આવશે કે અલગ આવશે?
આન્સર સેમ આવે, બટ જે પ્રમાણેની ઇન્ફોર્મેશન આપી હોય એ પ્રમાણેનો તમારે b ની ફોર્મ્યુલા યુઝ કરવી પડે. એટલે જ મેં લખ્યું કે when observation are small, હે
માર્ક્સ કપાઈ જાય.
શું
માર્ક્સ કપાઈ જાય કે ના કપાઈ જાય?
માર્ક્સ કપાઈ જાય, માર્ક્સ કપાઈ જાય. એટલે ઓબ્ઝર્વેશન સ્મોલ હોય ત્યારે આ ફોર્મ્યુલા, x બાર y બાર ઇન્ટીજર માં હોય ત્યારે સેકન્ડ ફોર્મ્યુલા. બરાબર? વેલ્યુ ઓફ ઓબ્ઝર્વેશન આર વેરી લાર્જ, x બાર y બાર નોન ઇન્ટીજર હોય, x અને y ની વેલ્યુ ડેસિમલ માં હોય, at that time you have to use this formula. See, when value of correlation is given, so byx is equal to r into sy upon Sx. Then if covariance of x and y is given, COV of xy upon Sx square, this is equal to Sxy upon Sx square. Then B એટલે byx, huh? So these are the different formula for finding out regression coefficient. On the basis of information provided to you, you have to apply different formula. Illustration 1. The following observations are obtained for life of cars in years of usage and their average annual maintenance cost of a specific model of car of a particular company. Obtain regression line of maintenance cost. Maintenance cost, that is y, on life of cars, that is x. So regression line of y on x. Also estimate the maintenance cost if the life of car is x year, that is 10 years. So when x is equal to 10 years, what will be the estimated value of average maintenance cost? Okay. Here you can see value of all the observations are small, less than 30. Then you have to apply first formula. Two, 4, 6, 8, 10, 20, 25 and 30. So first of all x square, then xy. Here you don't have to find out y square because you don't need it.
One 22. 90.
490. First of all, you have to find out x bar and y bar. That is sigma x upon n. 20 divided by 4. Then y bar. Sigma y upon n. 85 divided by 4. Now B n into sigma xy minus sigma x into sigma y upon n into sigma x square minus sigma x whole square. 4 into 490 minus 20 into 85 upon 4 into 120 minus 20 whole square. 4 into 490, that is 1960, minus 20 into 85, that is 1700. That will be 260. 480 minus 400. So 260 divided by 80. Now A, y bar minus bx bar, 21.25 minus 3.25 into 5. Will be 5. Regression line of y on x, or regression equation, regression model, one and the same thing. Y cap is equal to a plus bx. Cap means estimated value. So a, that is 5, and b 3.25x. So this is your regression equation. Now
सर x ની વેલ્યू નથી આવી.
what will be the estimated value of y? So 3.25 into 10 plus 5 is 7.5. Now y is annual maintenance cost in 1000 rupees. So it should be in 1000 rupees. So for 10 years of life, the maintenance cost will be 37.5 thousand rupees. Another thing, error of estimation. That is difference in value of actual value of y and estimated value of y. That is called error of estimation. Y minus y cap. When these both values are equal, then error of estimation will be 0. Illustration 3. In order to study the relationship between repairing time of accident damaged car and cost of repair, the time required in repairing in hours and repairing cost in 1000 rupees is given. Obtain regression line of y on x, that is repairing cost on repairing time. If the time taken to repair car is 50 hours, if the value of x is 50, find the estimated value of repairing cost, that is y. Now, first of all, we will find out x bar and y bar. Sigma x upon n. So here value of x bar and y bar both are integer and observation are large. So we will use second formula. X minus x bar, y minus y bar. X minus x bar whole square and x minus x bar into y minus y bar. So from each value of x we will subtract 34. Total has to be 0. Then from each value of y we will subtract 29. Four, 36, 81, 95. B sigma x minus x bar into y minus y bar upon x minus x bar whole square. 330 upon 228, 1.447. So approximately 1.45. Then A, y bar minus B x bar. 29 minus 1.45 into 34. Minus 20.3. Y cap is equal to A plus bx minus 20.3 plus 1.45 x. Now here estimated value of y is to be found out for the given value of x, that is 50. $52.2 in 1000 rupees. Unit is must.